All right, let's take a look at question number 14 in module 190301A in the self-test. How much output power must the cylinder produce? So we need our cylinder back. Let's bring that guy back. Okay, we remember we use the same cylinder in 12 and 13. So how much output power, important piece here, it'll determine the formula we use. Must the cylinder produce to accomplish the task described in 13? So remember, retracting in 7 seconds. Round off your answer to the nearest 2 decimal places. So if you need a hand with 13, go and watch the video of 13 on the channel there. But otherwise, we figured out the flow rate that was going to be required was going to be 199.54 liters per minute. Okay? And so already we have our flow rate. And why does that matter? Well, because our output power in kilowatts, the formula we're going to use is actually MPa, so megapascals, so the pressure, multiplied by our liters per minute, multiplied by 0.0167. And if you can't remember 0.0167, it's simply 1/60th. That's all it is. We're just converting the liters per minute into liters per second by multiplying them by 1/60th. That's all we're doing. Not that complicated. But anyway, that's what we're doing in the end there. So we already know our 199.54 fills this up. But now we need to get the pressure, and you'd think, oh, I can use the pressure from 12, but you can't. The pressure from 12 was on extension, and what we're dealing with in 13 is retraction. And we're assuming the 2,500 kilogram load from 12 is going to be used in the retraction side, because that just makes sense. It's attached to the moldboard. So what we need to do is redo the calculation with the retraction, saying that our load is 2,500 kgs. So again, remember, we can't use 2,500 kgs the way it is. We have to convert the 2,500 into newtons by multiplying it by 9.8. So let's do that again. So 2,500 times 9.8 is going to be 24,500 newtons. Okay, so we're going to need to know that. That's going to be our force that our cylinder is working against. But then we're going to need to know the surface area it's actually working against. And that's not going to be the big surface area. That's actually going to be this small surface area right here. And the way we can figure out what that is reusing some of the numbers we used in 13. In 13, we calculated that the area of our piston, the major area of our piston, was going to be 78.54 centimeters squared. So 78.54 centimeters, 54 centimeters squared was going to be this 10 centimeter diameter piston's area. So that works. And then we had to remember the rod, when we took the 5.5 centimeters and did our area calculation, was going to be 23.758 centimeters squared. And so then the annular surface area, or the effective surface area that we're going to actually be working on, is going to be the difference between those two numbers, because we're taking the rod away from the piston. So just simply subtract. And so let's grab our calculator. 78.54 subtract 23.758. And we're going to be left with 54.782 centimeters squared. That's our effective surface area. But remember, centimeters squared are not the target we're trying to get to, because remember Pascal's law, when we're going to use our force, oh, I got a little better triangle than the last one, force, pressure, area, our force was going to be in newtons, and our area needed to be in meters squared. So centimeters squared to meters squared, we need to do a conversion. Well, we need to remember it's 2 steps on the metric conversion chart, and multiplied by the exponent. So that's going to be 2. And so we have our 2 steps multiplied by exponent of 2, says we move 4 decimal places. 1, 2, 3, 4. So we have 0.0054 meters squared. And if we're going to round, we should really round that up to 5 meters squared. And if you go to your self-test, the numbers, you got to carry all your 8 decimal places to get that exact number in the self-test. So that's okay. I'm rounding, so we're going to get really, really, really close. All right, so we now have an area squared that we're acting on. Okay, so now we can enter those into our numbers. So again, we're looking for our pascals, or pressure, is going to be equal to our 24,500 newtons divided by 0.0055 meters squared. And that's going to give us a really long number. So 24,500 divided by 0.0055 gives us 4,454,545.45 pascals. Okay, but that's not what we can use in our formula. So if we look up where our output formula was up here, we have to be in megapascals, so MPa. So remember, mega is 6 decimal places from Pascal. So we're going to do that. We're going to go 1, 2, 3, 4, 5, 6. So we actually have 4.45 MPa. All right, at this point, we have pretty much all we need to know. We have all the information we need to make this work out. So what we're going to do is take our 4.45, multiply it by 199.54 times 1/60th, or 0.0167, and that's going to give us what our output power is. That tells us we need 14.828 kilowatts, because our output is always given to us in kilowatts. This would then be our answer for question 14.